All right, children. Lesson 4, Unit 2. It's just about to get real. We're about to throw some letters into your math. And as I'm always told, letters are for English and writing. Sadly, we bring them into our math starting with Lesson 4. So it's about to get real. But it's not too bad. We're going to go over it together. We've got a certain ceiling that's made up of tiles, and every square meter of ceiling requires 10 and 75/100 tiles. So we have to fill in this table with the missing values. So the key part here is that every square meter requires this many tiles. So that right there is giving us our first number. So 10.75. So we look at the table, and now that we have a pair that we know, we can find a constant of proportionality is simply just multiply by 10.75. So to fill out some of this table, we can take 10.75 and multiply by 10, and that's going to give us 107.5. That's pretty easy math, right? And then to take 100 and come back, we have to divide by our constant, which is 10.75. So you can show that with a calculator use of doing 100 and then dividing by that constant of proportionality, 10.75, and you get 9.3. All right, we're going to round to that to 9.3. I'm going to write it's about 9.3. All right. And so the one that really gets students mixed up on this one is, what in the world am I supposed to do with this A? Well, this A is representing any square meters of ceiling. It could be 5,000, 2, 4, 18, 7.2, whatever. So it's saying for any measurement of square meters of the ceiling, what do we do with that number to find out the number of tiles that we need? Well, we know that we take A and we're going to be multiplying it by our constant of proportionality. And so in algebra, we have an expression to show multiplication with numbers times letters, and we just put them side by side with each other and the letter right next to it after the number first. And that's it. You just have to write that in that box. No math needed to be done. It's just saying that if I want to know how many tiles would be used, I would just multiply whatever A is by 10.75. That's all that's saying. So no more work on that one. Let's look at the next problem. Problem number 2, you're taking a flight from New York to London. All right, we're going across the ponds, right? And this is a pretty long journey. The airplane's traveling at a constant speed that tells you it's proportional. And they give us an equation. This is what we start on with Thursday. We're getting equations to represent these proportional relationships, okay? So before I even write the equation, okay, I'm going to go ahead and set up a table just to kind of help get my mind wrapped around what's about to happen. And it tells me that in the equation relating the distance traveled in miles, D, to the number of hours flying, T, whenever they give you this stuff, traveled in miles, D. So D is going to be miles. And then T is going to be hours. I'm just going to go ahead and set this up. Okay, I got it set up over here. And they're telling me to find out what T is, to get to T. For me to get to T, I have to take 1 over 500 and multiply it by D. So D times 1/500 will tell me what T is. They are essentially, in this funky looking sentence right here, they are telling me what my constant of proportionality is all they're doing. All right. They're just telling me that I can multiply D's times 1/500 and find out what T's equal. That's all that's telling you. And I know it seems like a lot of jargon and busy language, but we get down to what all that means, and we got our table over here. It's going to help us out. So the question is, how long is it going to take this airplane to go 800 miles? Well, 800 is going to go here because it's under the miles. And just follow what our table just told us to do. We're going to find T by multiplying D miles by 1/500. So you can pull up a calculator for that. Okay. So we're going to, let's clear this out. We're going to multiply 800 times, not 8,000. That wouldn't work. 800 times a 500th, 1 over 500. There we go. Oh, not 5,000. I gotta be careful here. 500. And that gives us 8/5. So it's going to take us 8/5 hours. And I'm okay if you leave it as 8/5. Okay. You don't have to go and tell me that that's so many hours and minutes right now, unless it specifies for you to do so. It just says how long. So I'm going to roll with 8/5 hours as my answer. If you want to go a little bit further than that and tell me how many hours and minutes that is, that's fine. It's the same as 1 3/5 hours. And if you break hours up into fifths, those are going to be 12 apiece. So this would be an hour and 36 minutes if you really want to go there. But you don't have to. You can leave it like that for my case. I'm not going to get too upset about it. Okay. Problem number 3, I'm giving you tables and I want you to write the equation. So that's really what lesson 4 is about on Thursday. And so each table's got a proportional relationship. It should be really easy to find out what your constant of proportionality is. Okay. This one's times 4. This one over here is a little bit different. You got to divide to find this one. So to find out what that constant is, I'm going to take one number and divide it by the other. So 6.28. And I'm going to divide it by 2. And that will give me my constant times 3.14. Okay, so I got 2 different constants. One's super easy. One's a little bit more complicated. So we write down our constants, 4 and 3 14 hundredths. And then here's the big part. You just got to write this as an equation. Okay, so think about, to get what P equals, what did I do to S? I took S and I multiplied it by 4. Okay, so I'm going to write S times 4 equals P. And to get C over here on the right, I took D and I multiplied it by 3.14. Now, there's a more elegant way to write this as an algebraic equation, and that is P equals 4S for this one, and C equals 3.14D for that one. But they mean the same thing. We're just multiplying the left-hand column D by this to get C's, and we're multiplying the left-hand column S's by 4 to get all of P's on the other side. And that is your third problem and last problem of the week. Have a great weekend and good luck. Well, not weekend yet. I guess have a great rest of your week and good luck on the quiz this Friday.